Hello and welcome to this film, which is all about pH, and hopefully by the end of it you'll understand the relationship between pH and the concentration of H plus ions in a solution, and how looking at the pH can tell us about how acidic or basic a solution is. So first of all, let's have a look at what we mean by pH. Here's a definition of it. Okay, it's not spelt wrong, so this lowercase p means the negative log of something, and it's pH because it's the negative log of the hydrogen ion concentration in a solution. So square brackets means concentration of, H plus means H plus. Okay, so if we want to find the pH of a solution, we take the negative log of the H plus ion concentration. Or in other words, we say, what is the, well, if we find the log of something, we're saying, what power do we have to raise 10 to get this number? And if we're taking the negative of that, well, we stick a minus sign in front of it. Okay, so if I had a concentration of H plus of 10, the power I'd have to raise 10 to get 10 would be 1. But I stick a negative in front of that, so it's minus 1. So the pH of a solution with concentration of H plus ions of 10 moles per dm cubed is minus 1. If I've got a concentration of H plus ions of 1 mole per dm cubed, the pH is 0, because 10 to the power 0 equals 1. 10 to the power minus 1 is 0.1, so the pH of a solution with that concentration of H plus ions is 1, 2, 3, 4. And you can see that every time the concentration of H plus ions falls by a factor of 10, the pH is rising by 1 each time. And we can do numbers like this in our head perhaps, but numbers like this aren't quite so easy. But it's okay because we've got our calculator, so we just plug in 0.00002 into here. We take the negative log of it, do that on our calculator, and we find that the pH will be 4.7. And we can see here that the less acidic a solution is becoming, so the lower its concentration of H plus ions is, the higher its pH is. Right? Or the more basic it is becoming as the pH rises. Now let's have a look at some basic solutions. Now that we're talking about basicity, there we were just looking at acidic solutions. Well, there is one more acidic solution here, the pH of 6. But if pH equals negative log of H plus, then we can use log rules to decide that the concentration of H plus must equal 10 to the power negative pH. So in other words, the concentration of H plus if the pH is 6 is 10 to the minus 6 moles per dm cubed. And it's 10 to the minus 7 if the pH is 7. It's 10 to the minus 8 moles per dm cubed if the pH is 8, and so on and so forth. So 10 to the minus 11 moles per dm cubed if the pH is 11. And you can see that the H plus ion concentration is falling as the pH is rising. It's falling by a factor of 10 each time as the pH rises by 1. Okay, and the solution's getting more and more basic. We're moving to higher and higher pHs, or less and less acidic as the pH rises. If we get an odd looking number like this that we can't do in our head, well, this is still 10 to the power minus 10.32, but let's give that a number, and that's 4.8. times 10 to the minus 11. Okay, and did that by using my calculator, not in my head. Okay, now we could ask ourselves the question, what about neutral solutions? Because we've been doing it for acidic and basic solutions so far. It works just as well for neutral solutions, but to answer this question in a bit more detail, we're going to need to know about something called Kw, so we're going to leave that for another film. Okay, so hopefully now you can see how we can convert the concentration of H plus ions into pH and vice versa. You can see what pH of a solution tells us about how acidic or basic it is. If you've got any questions or comments, then please feel free to come and see me or to post a comment on YouTube.